Students, are you able to hear me? Are you able to hear me? Students, are you able to hear me? Okay. So the question which Venkataraya Bandare is asking is, why is chemical bonding in 19 videos in Hindi English course and 83 videos in English course? I'll give you the reason. What we have done is, students, very simple. A lot of you face problems in inorganic chemistry. Okay? Inorganic chemistry, I've explained it earlier also. Inorganic chemistry has, so this is inorganic chemistry, right? In this you have chapters like hydrogen, S block, P block, and I'm covering both 11th and 12th, so group 13 to 18, and D and F block, right? In each of these chapters, you will find some mention of electronic configuration, some mention of concepts that were discussed in periodic table, and some mention of chemical bonding, right? So what we have done is, in English course we have recorded these two chapters in a lot of detail. We have recorded these two chapters in a lot of detail so that you don't have to ratify, remember, cram reactions here, because the logic of these reactions which you will read here, be it hydrogen peroxide, be it nitric acid, be it phosphoric acid, H3PO4, sir, phosphoric acid, whatever you are going to read in these chapters is actually covered in these chapters, because this is where the logic is which gets applied in these chapters, right? You are understanding this, Venkataraya Bandare? Are you understanding what I am trying to say? Sumit, good evening. Shivanshu, good evening. Royal water, blue water, green water, red water, good evening. Harshika Pandey, good evening. So what I would recommend is, it is going to be a little bit lengthy, but go through these videos carefully. Go through these videos carefully. You will not feel uncomfortable with inorganic chemistry. Otherwise, what happens is, you are science students. When you have to remember everything, then you wonder whether you are history, sociology, political science students or science students. You don't have to cram anything. What you have to do is, you have to understand these two chapters very well so that you will understand the logic of the reactions in these chapters. Understood? Understood? Okay. So, Rollav Dangar, good evening. Sanjay Srivastava, good evening. So, everyone is ready. This is an extremely important chapter. Every year, 3 to 4 questions. 3 to 4 questions will come out of 45 questions from chemical bonding directly. And application of this chapter would be in at least 7 to 8 more questions out of these chapter as well as out of chapters in organic chemistry. So it is very, very important that you understand the logic of this chapter. That is why we are doing 2 live sessions. Keep going back to these chapters. Keep going back to topics like hydrogen bonding, dipole moment, right? Keep going back, because that is the logic which is covered in these chapters. And remember, inorganic chemistry, 15 questions out of 45 questions. 15 questions out of 45 questions in NEET chapter, 14 or 16, but on an average around 15 questions out of 45 would be in organic chemistry. And please understand one more thing. I have told you this again and again. I am telling you this thing again. Please understand this very carefully. Your lifeline in NEET exam will be decided in first 90 minutes. So in first 90 minutes what you will do is, you will do biology 90 questions. After that you will do organic plus inorganic 30 questions. This you will do in 50 minutes and this you will do in 25 to 30 minutes, so that you get time for calculations in physical chemistry and physics. You have to do this portion really well, 120 questions. These do not have calculations, so this is your comfort area. Please do these portions really well. These are 38 chapters, right? This is how many? 1, 2, 3. 3 chapters in class 11th, 12th. 1, 2, 3, 4. 1, 2, 3, 4. Polymer biomolecule 6. Chemistry in everyday life. 3 plus 6, 9 chapters here. Inorganic chemistry. Periodic table, chemical bonding to hydrogen, S block. Periodic table, chemical bonding to hydrogen, S block, P block 13 and 14. After that, P block 15 to 18, 6. DNF block 7. Coordination compound 8. And metallurgy 9. 9 chapters here. So total 38 plus 9 plus 9. 38 bio, organic and inorganic. These 56 chapters have 0 maths. You can say almost 0 maths. 56 chapters. So you have to do these chapters really well. That is why we have kept a lot of videos in this chapter, chemical bonding, right? Once you understand the logic of it, you will not have to cram anything. Once you understand the logic of it, you will not have to cram anything. Understood? Aniruddha explained this thing here. We have done these chapters, this chapter, chemical bonding, in a lot of detail in English chapter, because what happens is, this chapter is the basis of all of inorganic chemistry. So Anupam sir has done this chapter in a lot of detail. So when you get time, if you don't have time right now, when you have time, watch the videos. 83 videos, but they are all worth it. They are all worth it. Please understand. Same with the periodic table as well. Do them. We have done them in detail.
This time AIIMS has been associated with NEET. Therefore, these modifications have been done.
Okay. So students, the idea is, we don't know how difficult the exam is going to be. If they are doing AIIMS and JIPMER with NEET, it is possible that the exam might be slightly difficult. So what we have done is, we have done these 2 chapters in slightly more detail, so that even if AIIMS and JIPMER level questions come, you should not feel uncomfortable. Alright? So I will call Anupam sir and then we'll start. Just 1 minute. One minute students, we will start in a minute.
कौन इसमें टेस्ट में पास हुआ, ये सब कहाँ बताया?
आ जाइए सर. Alright students, you can say good evening to Anupam sir and then we'll start.
Good evening students. Good evening, good evening. Good evening, good evening. Ankit Raj, good evening. Aves Ghosh, hello, good evening. Now let us start without wasting any time. Right, the first question is The first question is, assuming that Hund's rule is violated, the bond order and magnetic nature of the diatomic molecule B2 is, right? Look here. According to Mott, molecular orbital theory, the structure by Mott of B2 can be written as sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. But since you know up to N2, that is in case of B2, C2 and N2, sp mixing occurs, and due to sp mixing, the energy of sigma 2pz becomes higher than pi 2p. So after sigma star 2s will come pi 2px equal to pi 2py, then will come sigma 2pz, then will come pi star 2px, pi star 2p, and so on. Now see, atomic number of boron is 5. So 5 into 2, that is B2 has total 10 electrons. So fill 10 electrons in molecular orbitals like 2 to 4 to 6 to 8. Now, if Hund's rule is allowed, then these two molecular orbitals are degenerate molecular orbitals, and in case of degenerate molecular orbitals, Hund's rule says degenerate orbitals will get one electron each, and then pairing of electron will take place. But here in this question it has been said Hund's rule is violated, and since if Hund's rule is violated, then one molecular orbital will get 2 electron. If it was not mentioned in the question Hund's rule is violated, then you will fill the molecular orbitals like 1 electron in each degenerate orbitals. But Hund's rule is violated, so both electrons, 2 electrons will get in this pi, and therefore you can see if Hund's rule is violated, then all electrons are paired, no unpaired electron, and therefore B2 will become diamagnetic. Actually, B2 is paramagnetic, but if it is mentioned in the question Hund's rule is violated, then you will say B2 will become diamagnetic, and bond order of B2 will be number of electrons in BMO minus number of electrons in ABMO upon 2. Number of electrons in BMO is 2 to 4 to 6, and number of electrons in ABMO 2 to 4 by 2. This will become 1. That means bond order of B2 will be 1, but its magnetic behavior will be diamagnetic, and therefore the right answer will be 1 and diamagnetic. Bilkul right, Sibanshu. Pi bonding, yes. In B2 you can see here 2 electrons of sigma BMO will form sigma bond, and 2 electrons of sigma anti ABMO will form sigma anti bond. Sigma bond will cancel sigma anti bond. Similarly, sigma bond, sigma anti bond cancel. 2 electrons of pi BMO will form 1 pi bond, and this 1 pi bond will be left here because no pi anti bond here. So here in B2 there is 1 bond, and this 1 bond will be pi bond because these 1 bond is formed by 2 electrons which are in pi BMO, and 2 electrons of pi BMO will form 1 pi bond, right? Sir, there is no short trick to calculate bond order. Ankit, first of all, avoid short trick, and first try your best to find bond order or anything by basic concept, right? And the basic concept is short trick. I have discussed some short tricks in LDS in videos. Watch it carefully and then you will get. Avoid short tricks. Short tricks there are many short tricks, and you can think over it, right? Now the second question is, move to the second question. Because if there is a straight question, then short trick will be applied. But if there is some change in the question, like here in this question it has been asked Hund's rule is violated, then the basic concept, the actual concept will be applied there. So always try to solve the problem by using actual concept. This short trick will what? Sibanshu, Mott is best, sir. Thank you. Yes, that is correct, but for a speed. No, a speed thrills but kills. Remember it. And okay, make practice. Okay, now move to the second question. Out of the 2 compounds shown below, the vapor pressure of B at a particular temperature is expected to be. Okay, listen. A is para-nitrophenol, para-nitrophenol, and B is orthonitrophenol. And remember, this is orthonitrophenol, and in orthonitrophenol there will be intramolecular H bonding in between O and H. This is intramolecular H bonding, that is chelation will take place. And since here H is involved in intramolecular H bonding, therefore no intermolecular H bonding will be formed in this case. And therefore if the molecule is involved in intramolecular H bonding, then no association of molecules will take place. But in case of para-nitrophenol, you can see here, this is para-nitrophenol. In para-nitrophenol, chelation is not possible because there is a large distance between H and O, so intramolecular H bonding is not possible. And if intramolecular H bonding is not possible, then intermolecular H bonding can take place in between 2 molecules of para-nitrophenol. Suppose this is 1 molecule of para-nitrophenol, this is its neighboring molecule of para-nitrophenol, and in between 2 molecules of para-nitrophenol, intermolecular H bond can form here. This is intermolecular H bond, and due to formation of intermolecular H bond, association of molecules will take place in this case. And since association of molecules are there, molecules are associated by hydrogen bond, intermolecular hydrogen bond, so molecules will have less tendency to get evaporate, that is para-nitrophenol will have lower vapor pressure. But in orthonitrophenol, there is intramolecular H bonding, so no association of its molecules by intermolecular H bond. Molecules are not associated in this case, so there is less interaction between molecules, so more number of molecules go into the vapor phase, and therefore the vapor pressure of orthonitrophenol will be higher than that of the paranitrophenol. So its answer will be 1, right? What is chelation? Chelation means formation of a stable ring. Look here, due to formation of intramolecular H bonding in between H and O, you can see 1, 2, 3, 4, 5, 6. 6-membered ring is formed here. And as you know, 5 and 6-membered rings are stable. And formation of a stable ring is called chelation. Okay? Yes. Next, now move to question number 3. Question number 3 is, which of the following pairs of species would you expect to have largest difference in a spin-only magnetic moment? Look here. A spin-only magnetic moment, that is mu s, is calculated by this formula. Under root n into n plus 2 bm. Bm means Bohr magneton. This is the unit of magnetic moment. And here n is number of unpaired electrons. So if more is the number of unpaired electrons, more will be the spin-only magnetic moment. If number of unpaired electrons is same, then a spin magnetic moment will be the same. So here in this question number 3, it has been asked, which of the following pairs of species would you expect to have largest difference in a spin-only magnetic moment? Largest difference in the number of unpaired electrons will give the largest difference in a spin-only magnetic moment, right? So in MOT, in the video lecture of MOT, you have seen in O2, number of unpaired electron is 2. But in O2 plus, number of unpaired electron is 1. Similarly, in O2, number of unpaired electron is 2. And in second option, O2 2 minus. And in O2 2 minus, number of unpaired electron is 0. In the third option, in O2 plus, number of unpaired electron is 1. And in O2 2 minus, number of unpaired electron is 0. And in fourth option, in O2 minus, superoxide ion, number of unpaired electron is 1, and in O2 plus, number of unpaired electron is also 1. So here difference is 2 minus 1, 1, 2 minus 0, 2, 1 minus 0, 1, 1 minus 1, 0. So largest difference in the number of unpaired electron is in between O2 and O2, in between O2 and O2 2 minus. In O2, number of unpaired electron is 2. In O2 2 minus, number of unpaired electron is 0. So here difference is 2, which is the largest difference in in number of unpaired electrons. So there will be largest difference in a spin-only magnetic moment also. So its answer will be 2. Correct option will be 2. Everyone got? Shivanshu 2, Akhil 2, right. Now move to question number 4. Now move to question number 4. Question number 4 is, The correct order of the bond angles is, as you know, in ammonia, hybridization is sp3. So its electronic geometry will be tetrahedral, but molecular geometry is pyramidal, sp3 and one lone pair. So its bond angle is near to 107 degree. In water, you can see hybridization of O is sp3, but here there are two lone pairs on central atom O. So bond angle here will be lesser than that of ammonia, about 104.5 degree. But in pH3, I have discussed in the video lecture, in pH3 and in H2S, Drago rule is applied. And where Drago rule is applied, in such molecules where Drago rule is applicable, almost pure p orbitals take part in bonding. And where almost pure p orbitals take part in bonding, bond angle will be near to 90 degree. In phosphine, bond angle is about 93.8 degree. And in H2S, bond angle will be even lesser than that of phosphine, because in phosphine, P has one lone pair, but in H2S, central atom sulfur has two lone pair, and more number of lone pair on the central atom, lesser will be the bond angle. So in H2S, bond angle will be even lesser than that of phosphine, about 92.5 degree. So the correct order of the bond angle will be first ammonia, then water, then phosphine, and last H2S. So its right option will be 1. Anish Ghosh, sir, what is Drago rule? Can you please explain, sir? Anish, watch the video. In video, Drago rule has been discussed. Drago rule, listen. A molecule will obey Drago rule if it follows or obeys the following 4 conditions. And what are these 4 conditions? First condition is the central atom should be of group 15 or of group 16, right? Second condition is central atom should be of the 3rd period or of higher periods. The third condition is central atom should have one or more lone pair. And the fourth condition is the electronegativity of the substituent should be less than or equal to 2.5. And you can see in phosphine and in H2S, all these 4 conditions are meeting. And therefore, these molecules obey Drago rule. And it is said, a molecule which obeys Drago rule is excluded from hybridization. In such molecules, almost pure p orbitals take part in bonding. And since pure p orbitals take part in bonding, therefore bond angle in such molecules is near to 90 degree. This is Drago rule, but for more discussion, more knowledge, watch the video. This has been discussed in video, right? Okay. Next, question number 5. Move to question number 5. Question number 5 is, the volatility of HF is low as compared to other hydra acids of halogen? Because, listen, hydra acids of halogens are HF, HCl, HBr and HI. These are the hydra acids of halogen acids, right? Now, as you know, boiling point is inversely proportional to volatility. Volatility means tendency to get evaporated. I mean tendency to pass into the gaseous state, right? That is, more high boiling point means less volatility, and less boiling point means high volatility. And the general rule is, higher the molecular mass, molar mass of the substance, higher will be the boiling point, and so lesser will be the volatility. And according to general concept, the least molecular weight among all these four is HF. So since HF has lowest molecular weight, therefore it should have lowest BP and highest volatility. But actually it is not so, because in HF there is intermolecular H bonding. In HF you can see H is covalently bonded to highly electronegative atom F. And so molecules of HF get associated together by means of a strong intermolecular H bonds, and due to association of its molecules by means of intermolecular H bonding, its effective molar mass becomes high, and therefore HF has high BP and so low volatility. So among these four, the highest boiling point is of HF, and so least volatility is of HF. But in case of HCl, HBr and HI, there is no hydrogen bonding. And since no hydrogen bonding, so in these three, the general concept will be applied. That is, in HCl, HBr and HI, highest molecular weight will be of HI, and so among these three, highest boiling point will be of HI. So if I say order of boiling point of these four, then answer will be highest boiling point will be of HF due to association of its molecules by means of intermolecular H bonds. Then will come HI, then HBr, and least boiling point will be of HCl. And as you know, the order of volatility is reverse of the order of boiling point. So among these, HF will be least volatile and HCl will be the most volatile here, right? So here the answer will be the volatility of HF is low, that is least among these four, due to a strong hydrogen bonding, intermolecular H bonding. So answer should be 4, right? Okay, due to H bonding, right? Listen, one thing is due to H bonding, but if it is asked among HF, HCl, HBr, HI, which is most volatile, then answer will be HCl. HCl here is most volatile and HF is least volatile here. Now move to question number 6. Question number 6 is the experimental value of the dipole moment of HCl is 1.03 dBi. Listen, dBi is the unit of dipole moment, and 1 dBi is equal to 1 into 10 to the power minus 18 ESU into centimeter. ESU, that is electrostatic unit, which is the unit of CGS unit of charge, ESU, into centimeter. 1 dBi is equal to, remember this, 1 dBi is equal to 1 into 10 to the power minus 18 ESU centimeter. And experimental dipole moment means observed dipole moment, actual dipole moment, mu naught of HCl is given 1.03 dBi. That is 1.03 into 1 dBi. 1 dBi means 1 into 10 to the power minus 18. So 1.03 dBi will be equal to 1.03 into 10 to the power minus 18 ESU centimeter. And the length of HCl bond is 1.275 angstrom. Look here. This is HCl, and here there will be delta minus charge, and on H there will be delta plus. But on finding calculated dipole moment, this is calculated, mu calculated. Calculated dipole moment is find by Q into D. Q is charge on either atom assuming complete heterolytic fission. If you will carry out complete heterolytic fission of this covalent bond, then on Cl minus 1 will develop and on H plus 1 charge will develop. So one unit charge will develop on either atom, and 1 unit charge in CGS is 4.8 into 10 to the power minus 10 ESU. ESU is the CGS unit of charge in CGS unit, and charge of 1 electron or 1 proton in CGS is 4.8 into 10 to the power minus 10 ESU. Remember this, 1 unit charge in ESU is 4.8 into 10 to the power minus 10 in CGS. And D is bond length, and in question bond length is given 1.275 angstrom, but since this is in CGS, so distance here should be in centimeter, and you know 1 angstrom is equal to 10 to the power minus 8 centimeter. So this will become 4.8 into 1.275 into 10 to the power minus 10 minus 18 ESU centimeter. That is 4.8 into 1.275 dBi, because 10 to the power minus 18 ESU centimeter equal to 1 dBi. So mu observed, that is experimental dipole moment, is 1.03 dBi, and mu calculated, that is theoretical dipole moment of HCl, is 4.8 into 10 to the power 4.8 into 1.275 dBi. So remember this formula, percent ionic character is calculated by this formula, mu observed upon mu calculated into 100. Here in this question, mu observed is 1.03 dBi upon mu calculated is 4.8 into 1.275 dBi into 100. Calculate this. This will come near to 17% approx. Approximately near to 17% ionic character. So answer will be 3, that is 17. Other HX are also electronegative. Why H bonding is not possible between them? Ankit, you have not watched the video carefully. H bonding is formed when H is covalently bonded to highly electronegative atoms like phone, F, O and N. In these cases, highly electronegative like F, O and N. Okay. Next. H bonding is also the phenomenon of size, not only yes. H conditions for the formation of H bonding, I have discussed this in video, depends upon electronegativity as well as the size of the atom. Okay, now move to question number 7. Question number 7 is, in which of the following compound all the bond angles are equal? All the bond angles are equal. So see here, first option is SF4. SF4. Find its N. N means sum of valence electrons. Valence electron of F is 7. So 7 into 4 plus valence electron of sulfur is 6. So it will come 7 4 ja 28 plus 6 34. Now divide 34 by 8. 8 4 ja 32. So quotient will be 4 and remainder will be 2. Quotient is 4 means number of sigma bonds will be 4 and remainder is 2. 2 by 2, that is number of lone pair on central atom S will be 1. 1 lone pair and 4 sigma bond. So steric number of sulfur here will be 5 and steric number of sulfur is 5 means 5 orbitals of it will participate in hybridization, and 5 orbitals means 1s, 3p and 1d, and its electronic symmetry will be TBP. And TBP is like this. This is TBP, and in TBP, as has been discussed earlier in video, in TBP lone pair occupies the equatorial position. So at one equatorial position lone pair will be present. Now F, these two F axial and these two F equatorial. This F, angle between these two equatorial F will be near to 120 degree approx, actually slightly lesser than 120 degree, and between this will be axial angle near to 90 degree. So in TBP, you know, there are two types of adjacent bond angles, 120 degree and 90 degree. So all bond angles are not equal here. The second option is CCl4. Carbon tetrachloride. First find its N, that is sum of valence electrons of it. Valence electron of Cl is 7, so 7 into 4 plus valence electron of carbon is 4, so it will come to be 32. Now divide 32 by 8, quotient will be 4, remainder will be 0. Remainder is 0, so no lone pair on central atom carbon, and quotient is 4, so number of sigma bonds with carbon 4. So steric number will be 4. So 4 orbitals of it will participate in hybridization. And 4 orbitals means 1s and 3p. So here the hybridization of carbon will be sp3. Since hybridization is sp3, no lone pair on the central atom and all substituents are same. Therefore, it will have regular geometry. No distortion in it will take place. And as you know, in a regular tetrahedron, there are 6 adjacent bond angles, and each adjacent bond angle will be of 109 degree, 28 minute, which is called normal tetrahedral angle. So in CCl4, all the bond angles are equal and is of 109 degree 28 minute. Haroop Singh, why divided by 8? please watch the video, because in less time in discussion part, in live session, it is very hard to discuss it, right? Okay, watch the video. In video, these topics have been discussed clearly with many examples of it. This is the rule. Now move to question number 8. Move to question number 8. The structure of Diborane B2S6 contains. In video part, the structure of Diborane has been discussed clearly. And in the structure of Diborane, you have seen, it has been discussed clearly. There are two 3C2E bonds, which are also called banana bonds or tau bonds. That is, two bonds are banana bonds, that is 3C2E bonds, 3-centered 2-electron bonds, and 4 bonds are normal covalent bonds. These 4 bonds are normal covalent bonds, that is of the type 2C2E bonds. Normal covalent bonds are of the types 2C2E, that is 2-centered 2-electron bonds. This is 2C2E bonds. This is also 2C2E bonds. So in Diborane, there are 4 2C2E bonds and 2 3C2E bonds, that is 2 banana bonds. So its right answer will be 1. The structure of Diborane contains 4 2C2E bonds, yeah, and 2 2C2E, no, 3C2E, not 2C3. So 1 is wrong. 2 2C2E wrong, 4 2C2E and 4 3C2E, no. 2C2E bonds 4, but 3C2E bonds are 2. So its answer will be none. That is 4th, none. Right? Okay? 4. Harsika Pandey, very good. 4. None. Very good. Supriya Praveen. Right. Move to question number 9. In which of the following is not correctly match between given species and type of overlapping? This is the part of VBT, and in video this part has been discussed clearly with many examples in many cases. So you can see here, first is XeO3. First find its hybridization, okay, and for it the rule is first find N. N is sum of valence electrons of all the atoms. So valence electron of O is 6, 6 into 3 plus valence electron of xenon is 8. 6 3s are 18 plus 8, 26. 26 by 8. 8 3s are 24. So quotient is 3 and remainder is 2. Remainder is 2, that means there will be 1 lone pair on the central atom and 3 sigma bonds. So steric number of xenon here is 4. So 4 orbitals of it will participate in hybridization, and 4 orbitals mean 1s and 3p. So here hybridization of xenon will be sp3. And hybridization is sp3, so 4 sp3 hybrid orbitals will be here. 1 sp3 hybrid orbital will have lone pair, and 3 sp3 hybrid orbital will form sigma bond, because you know hybrid orbitals form sigma bond, not the pi bond. So here 1 sp3 hybrid orbital has lone pair and 3 sp3 hybrid orbital will form sigma bond. Now O has no charge, therefore if O has no charge, then such O must be bonded by 2 bonds. So 3 pi bonds will be there in this. Now, as you know, pi bond is formed by non-axial d orbitals. So you may see sp3 hybridization. So 4 sp3 hybrid orbitals are there. One sp3 hybrid orbital has lone pair and 3 sp3 hybrid orbitals form these 3 sigma bonds. Now S and 3p all get involved in the formation of sigma bond in hybridization. So now the d orbitals, that is non-axial d orbitals, will participate in the formation of pi bond. So all the 3 pi bonds here will be formed by pi d orbitals. So it's d, so d pi, and p orbital of O. So all these 3 pi bonds will be of the type p pi d pi, p pi d pi, p pi d pi, and this is also p pi d pi. So option 1 is correct. It has been asked in which of the following is not correctly matched. So answer is not 1. 1 is correct. We have to find incorrect option. Yes. Okay, next, in H2SO4, you know its structure is S double bond O, S double bond O, OH and OH. Now here there are 4 sigma bonds which will be formed by the 4 sp3 hybrid orbitals. So both pi bonds will be formed by p pi d pi. So here both pi bonds are p pi d pi, so 2 d pi p pi bonds, right? In SO3 you can see the structure of SO3 is this. Now see here, the number of sigma bonds here is 3. So 3 orbitals of it will participate in hybridization. So here hybridization of sulfur is sp2. sp2 means 3 sp2 hybrid orbitals are forming 3 sigma bonds. Now there is 1 p orbital left which will form 1 pi bond, and 2 pi bonds will be formed by 2 non-axial d orbitals of sulfur. So here in SO3, 1 pi bond is of the type p pi p pi, and 2 pi bonds will be of the type d pi p pi, d orbital of S and p orbital of O. So 1 p pi bond and 2 p pi d pi. But here it has been mentioned 3 d pi p pi. This is wrong. So its answer will be 3. Right. Tanuj Prakash. Yes, I am going 9. Next, move to question number 10. B3N3H6 plus solution of HCl. Select correct about above reaction. Right. B3N3H6. B3N3H6. This is called Borazine or inorganic benzene. This is called Borazine or inorganic benzene, and this is isoelectronic with benzene, and its structure is like that of benzene. Here one boron, one N, one boron, one N in alternate position. So ring of 6 atoms, and N has one lone pair as you know, and boron has one. First give one H with all atoms. Now N has one lone pair and boron has one vacant 2p orbital. So N will give its lone pair to the vacant 2p orbital of boron and will form one coordinate bond here. Here also one coordinate bond, here also one coordinate bond, which will be of pi nature like that of back bond. This is the structure of borazine, which is isoelectronic with benzene. Like benzene, this is also aromatic and planar, non-polar, everything. Now this is borazine, this is inorganic benzene, and you have to react this with HCl. Now look here, HCl will give H plus and Cl minus. Here N has one lone pair and N will donating its lone pair to boron. But when H plus will come, then N will have the choice. Either it may give its lone pair to boron or it may give its lone pair to H plus. But H plus is better electron acceptor than that of boron because H plus is smaller in size. It already has plus charge. So it will have more electron withdrawing tendency, and so H plus is more stronger Lewis acid. Therefore, when H plus will come, then N will give its lone pair to H plus. So here one H will be added on each N, okay, on each N. And now boron will have left one vacant 2p orbital. So here Cl minus will act as a Lewis base, and Cl minus will donate its lone pair to the vacant 2p orbital of boron. And therefore what will happen here, B3N3H6 show addition reaction and produce B3N3H9Cl3 in which Cl bonded to boron, right? So then what will happen? I am writing here HCl will give H plus and Cl minus. Since H plus is better electron acceptor than boron, therefore now N will give its lone pair to H plus and H plus will add it to N. So here one H plus and here one H plus. I am writing here the product which will be formed here. Now boron has one vacant 2p orbital, so Cl minus is left. So Cl minus will donate its lone pair to the vacant 2p orbital of boron, and Cl minus will be added to boron, and so this will be the product. So its right answer will be 3, and here Cl is bonded to boron, right? So answer 3. Supriya, Praveen, not 4. Cl can't be bonded to N because in HCl H plus is there and Cl minus. Cl minus is already electron rich and N also has lone pair, it is also electron rich. So they will repel each other. Cl minus is Lewis base, anions are Lewis bases. So Cl minus will be added to Lewis acid, and here boron has vacant 2p orbital. Boron is not completing its octet, so boron will get lone pair from Cl minus. So answer 3. Okay. Now Ankit Raj, is resonance is possible here in borazine? Yeah. Resonance is possible, therefore it is aromatic. What I said, it is aromatic like that of benzene, but it is not as stable as benzene. That is, aromaticity is there, resonance is there, but resonance is not as powerful as in benzene here. Yes, now move to question number 11. Question number 11 is, which of the following compounds have the same number of lone pairs with their central atom? Same number of lone pairs with the central atom. And this is a very simple question, and this may be calculated by using the rule which has been discussed in video. First option is XeF5 minus, and here N will be 7 into 5 plus 8 plus, it has one negative charge, so add 1. So 7 5s are 35 and 8, 43 and 1, 44. So now divide 44 by 8. 8 5s are, quotient is 5 and remainder is 4. Remainder is 4. Remainder means number of non-bonding electrons with the central atom, and number of lone pair is R by 2. R is 4, so R by 2, that is 4 by 2, that is here central atom xenon has 2 lone pair. The next option is BRF3, BRF3. Okay, so first find N. Valence electron of F is 7, so 7 into 3 plus valence electron of boron is also 7, so 7 4s are 28, 28 by 8, 8 3s are 24, quotient 3, 8 3s are 24, so remainder 4, so 4 by 2, that is 2 lone pair on the central atom here also. Now the next option is XeF2, xenon difluoride. It's N. 7 2s are 14 plus 8, 22. 22 by 8. 8 2s are 16, quotient 2 plus remainder 6. Remainder 6, so 6 by 2, that is 3. Central atom has 3 lone pair. And the fourth option is triple methylene. Triple methylene. Triple methylene. What is triple methylene? There is some error. What is triple methylene? There may be some typing mistake here. Make it not triple methylene. It may be triphenyl amine or trimethyl amine. This may be trimethyl amine, and trimethyl amine is this. And it has 1 lone pair. So in this question it has been asked same number of lone pair. So same number of lone pair is in XeF5 minus and in BRF3, 1 and 2. 1 and 2. Option 3. Correct option 3. 1 and 2. Right? Supriya 3. Right? 1 and 2. Good. Methylene is CH2, yes. Listen, CH4 is methane. When one H is removed from methane, CH3, this is called methyl. When one more H is removed from this becomes CH2 and 2 bond free. This is called methylene. And one H is removed more further, then this becomes CH and 3 bonds free, and this is called methene, METHEINE. These are the organic radicals, right? So here's some typing mistake here. Triple methylene. Triple methylene means 3 methylene, but methylene has no lone pair. If it is so, okay. Now move to question number 12. Now move to question number 12. Question number 12 is, consider the following compounds and select the incorrect statement from the following. Yes, NH3, PH3, H2S, SO2, SO3, BF3, PCl3, IF7, P4 and H2. Yeah, but it will have no lone pair there, Shivanshu. Okay, So there may be some error. There should be here one example such which has some lone pair on the central atom. That's why I said there may be some typing mistake here. Okay. Yes. Now consider the following compounds and select the incorrect. Okay. First is 3 molecules out of given compounds involve sp2 hybridization. As you know, in ammonia, in NH3, hybridization of N is sp3. In PH3, hybridization of P is either said sp3 or according to Drago rule, it is excluded from hybridization also. In H2S, either hybridization of sulfur is said to be sp3 or according to Drago rule, it is excluded from hybridization. Yes, in SO2, hybridization of sulfur will be sp2. In SO3, hybridization of sulfur will be sp2. In BF3, hybridization of boron will be sp2. In PCl3, hybridization of P will be sp3. In IF7, hybridization of I will be sp3d3. In P4, hybridization of P is sp3. In H2, no hybridization. So first option is correct. 3 molecules have sp2. So this is not the answer. I have to find incorrect. 3 molecules are hypervalent compounds. Hypervalent compounds means those covalent compounds in which central atom has more than 8 electrons. So here SO2 hypervalent compounds are here SO2, SO3. These have been discussed in the video. SO2, SO3, IF7. Only these 3 molecules here are hypervalent. So 3 molecules are hypervalent, right? Correct. So this is not the answer. 6 molecules out of above compounds are non-planar in structure. Non-planar. Okay. So look here. Non-planar. Ammonia, as you know, this is pyramidal. So it is non-planar. PH3, this is also pyramidal. So non-planar. H2S. H2S is planar because it is bent like that of water, bent or angular. So this is planar. SO2, this is trigonal planar. SO3 trigonal planar. BF3 trigonal planar. PCl3 is pyramidal. So PCl3 is non-planar. IF7, this is pentagonal bipyramidal and this is non-planar. And H2P4 is tetrahedral or pyramidal. So P4 is non-planar, but H2 is linear. Linear molecules are planar. So non-planar molecules are 1, 2, 3, 4, 5. Only 5 molecules out of these are non-planar. Answer 3 is incorrect here. So it will be the answer here. Everyone, right? 3. Answer is 3 here. Okay. Next, move to question number 13. 13 is the molecular orbital diagram of Cn plus. First write the configuration of Cn. In both carbon and N, sp mixing takes place. Therefore, here the energy of sigma 2b will be higher than that of pi 2b. So first sigma 1s, then sigma 2s, sigma 1s, then sigma star 1s, next sigma 2s, sigma star 2s, then will come pi 2px equal to pi 2py, then will come sigma 2pz, then will come pi star 2px, and so on. Now total number of electrons you can see 7 plus 6 13, so 2 to 4 to 6 8 10 12, so 1 13, this is 13. Now you have to find the structure of Cn plus, it has 1 plus, so remove 1 electron from the last molecular orbital, so remove this. So here the configuration will become, in place of sigma 1s and sigma star 1s, you can write kk, inner shell of C and inner shell of N. So this will become kk sigma 2s, sigma 2s, sigma 2s, sigma star 2s, then pi 2px 2, pi 2py 2, because 1 electron has been removed, so this is 0. Since this has 0 electrons, so no need to write it. So this will be the right structure by mot of Cn plus. So its answer will be 1. Everyone right? Right. Next, move to question number 14. Which right order of dipole moment of the following compounds? Order of dipole moment of the following compounds. So see it in one, you can see, this will see, if its bond moment is x and its bond moment is x and angle between these two bond moments is 180 degree, so its resultant will become 0. It will cancel to this. So only the dipole moment of this will be due to this CCl bond, and therefore dipole moment of 1 and move to options. Right. 1 and 3. 1 and 3 will have the same dipole moment, because in option 3 you can see if this bond moment is x, this bond moment is x, and angle between these two is 180 degree, so this will cancel this. Now if this bond moment is x, this bond moment is x, and angle between these two is 120 degree, so resultant of x and x at theta 120 degree will be x. So these two will have the same dipole moment. So 1 and 3 have equal dipole moment, and therefore the correct option is 3 here. The highest dipole moment will be of 2. In 2, it will have highest dipole moment. How? Look here. This is option 2. Yes. Now you can see, if this dipole moment is x, this dipole moment is x, and this will also x, so this is x, and theta here is 120 degree, so resultant will be x, and so its resultant will be x, which will come over this, and this has already 1 Cl, and 1 Cl will come over it at 0 degree, and so resultant will be here very high, will be addition there, because resultant is calculated as, according to factorial addition, resultant are equal to under root p square plus q square plus 2pq cos theta. If theta is 0 degree, then cos 0 degree will be 1, so there will be addition here. So Example 2 will have the highest dipole moment. So its answer will be 3. 5 and 6 has equal dipole moment, you can see. No. 5 and 6 no, has no equal dipole moment, because in 5 the dipole moment will become 0, because in 5 you can see this is para-dichlorobenzene. If its bond moment is x, its bond moment is x, and theta is here 180 degree, so this is x or theta is 180 degrees, so resultant will come 0, so its dipole moment will be 0. And in 6 one Cl is missing. Look here, 6 is this. This is 6, 135 trichlorobenzene. So you can see its bond moment is x, its bond moment is x. So, and theta is 120 degrees. So this is x, q is also x, theta 120 degree, cos 120 degree, value of cos 120 degree is minus half. Solve it, this will come x, and resultant of these x and these x will be x in between these. So this is resultant x. Now this x and this bond moment is also x, and theta in between these x and these bond moment x is 180 degree. So if this is P, this is Q, theta 180 degree, so resultant will become 0. So its dipole moment will also become 0. Its dipole moment will also become 0. So right answer is 3. Everyone got? Yes, 5 and 6 have same dipole moment. Right, move to question number 15. Now move to question number 15. The color of halogens progressively depends from fluorine to iodine, because as you know, you should remember the color of halogens. Color of F2 is light yellow. The color of chlorine is greenish yellow. The color of chlorophyll, greenish yellow. The color of bromine is red, and the color of iodine is violet. Right? And color in molecules is due to homo-lumo transition of electron. This has been discussed in the video part, in video lecture of MOT, that is of molecular orbital theory. Color in molecules is generally due to homo-lumo transition of electron, and if in homo-lumo transition of electron visible light is absorbed, then molecules will have color. Now question number 15. Halogens have higher atomic number absorb light of longer wavelength, since the difference in energy between the ground state and excited state decreases as the atomic number increases. Here ground state means HOMO and excited state means molecular orbital of LUMO. Right? So as you know, as you go down the group, that is as atomic size increases or as atomic number increases, the energy gap in between HOMO and LUMO decreases, and as energy difference in between HOMO and LUMO will decrease, the electron will absorb visible light of lesser energy, that is lesser energy means of higher wavelength, and therefore color will depend there. So its right answer will be 1. Shivanshu 1, very good. Now move to question number 16. This is very important question, so learn such type of questions. This question has been asked frequently, and since this time AIIMS and JIPMER may also be associated with NEET, so some difficulty levels or some difficult questions probably may be asked, therefore you should be prepared for that. So now the next question, question number 16 is, the bond order in NO is 2.5 while that in NO plus is 3. Which of the following statement is true for these two species? In NO, bond order is 2.5 and in NO plus bond order is 3. And you know, more bond order, more bond strength, more bond energy and lesser bond length, and you have to choose the correct statement. So the correct statement will be bond length in NO is greater than in NO plus. Very good, because in NO bond order is lesser than that of NO plus, and lesser bond order than greater bond length. So its answer, true answer will be 2, right? Anis, right. Bond order is inversely proportional to bond length. Supriya, very right. Now move to question number 17. In which of the following ionization processes the bond order has increased and the magnetic behavior has changed? Look, in NO, one unpaired electron is there and bond order is 2.5. But in NO plus, bond order becomes 3, that is bond order has increased. But in NO plus, no unpaired electron is there, so it becomes diamagnetic. So NO is paramagnetic, NO plus is diamagnetic, that's magnetic behavior has been changed as well as bond order also has been increased. So this is the right answer. So right answer of question number 17 is magnetic behavior has changed. Magnetic behavior has changed. NO is paramagnetic, NO plus is diamagnetic. So here also magnetic behavior has been changed, but in O2 bond order is 2 and number of unpaired electron in O2 is 2, and in O2 plus bond order becomes 2.5. Bond order is increased, but O2 plus has one unpaired electron. So O2 is also paramagnetic, O2 plus is also paramagnetic. Magnetic moment has been changed here, but magnetic behavior has not been changed. Change of magnetic behavior means diamagnetic to paramagnetic or paramagnetic to diamagnetic. But O2 and O2 plus both are paramagnetic, so magnetic behavior has not been changed here. So its right answer will be 1. Okay? Shivanshu, no, 2. In O2 to O2 plus, bond order has been increased, but O2 is also paramagnetic, O2 plus is also paramagnetic. Both are paramagnetic. Their magnetic moment has been changed, but magnetic behavior has not been changed because both are paramagnetic. Magnetic behavior, change in magnetic behavior means to become paramagnetic to diamagnetic or diamagnetic to paramagnetic. So answer is 1. Okay. Now move to question number 18. Question number 18. Using MO, molecular orbital theory, predict which of the following species has the shortest bond length. Highest bond order means shortest bond length, and answer will be in O2 plus, in O2 minus, bond order will be 1.5. In O2 2 minus, bond order will be 1. In O2 2 plus, O2 2 plus, bond order will be, listen, in O2 2 plus, how many electrons are there in O2 2 plus? You can see here. 8 2 ja 16 and 2 plus means 2 electrons have been left. So O2 2 plus has 14 electrons, but to write the MOT, molecular orbital structure, by MOT of O2 2 plus, first you will have to write the structure of O2. So write structure of O2, sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. Now after N2, that is from O2 F2, no sp mixing takes place. So here in this case, the energy of sigma 2pz will be lesser than that of pi 2p. So after this will come sigma 2pz, then will come pi 2px equal to pi 2py, then will come pi star 2px, then will come pi star 2py, and so on. Now total electrons 16, 2 to 4, 6, 8, 10, 12, 14, and according to Hund's rule, these are degenerate molecular orbitals, so 1, 1. This is the structure of O2. Now you have to make the structure of O2 2 plus, and in O2 2 plus 2 electrons should be removed. So remove these 2 electrons, so no need of it. Now find bond order of this, then number of electrons in BMO 2, 2, 2, 2, 2, that is 2 to 4 to 6 to 8 to 10. Number of electrons in ABMO 4 by 2, so 6 by 2, 3. Here bond order will be 3 because it is isoelectronic with N2. N2 has 14 electrons, you know, and O2 2 plus has 14 electrons. Therefore, since O2 2 plus is isoelectronic with N2, and in N2 you know there is a triple bond, bond order 3, so therefore in O2 2 plus bond order will be 3. In O2 plus bond order is 2.5. So highest bond order is of O2 2 plus, and highest bond order means shortest bond length. So answer of question number 18 will be 3. Make it correction. Here answer is given 4. No, make it correct. Its answer will be 3. Note it. In question number 18, right answer will be 3. Now question number 19. Question number 19. The molecule having a smallest bond angle is of a smallest bond angle. You know, NCl3, PCl3, ASCl3 and SbCl3, right? Substituents are same, central atom same, hybridization of central atom same. And if central atom hybridization of central atom same, substituents are same, then as you know, as we go down the group, electronegativity of central atom will decrease. On moving down the group, electronegativity of the central atom will decrease, and as electronegativity of the central atom will decrease, the bond pair will go away and away from the central atom, and as bond pair move away and away from the central atom, bond angle will decrease and decrease, right? So a smallest bond angle will be of SbCl3. Learn this, remember this. Nearer the bond pair to the central atom, greater will be the bond angle, and farther the bond pair from the central atom, lesser will be the bond angle. Right? These things have been discussed clearly in videos. Watch it carefully. Now move to question number 20. In 20, according to molecular orbital theory, which of the following statement about the magnetic character and bond order is correct regarding O2 plus? First write the structure of O2 plus by Mott, and you will see in O2 plus there is one unpaired electron. So it is paramagnetic, one unpaired electron it has, and its bond order is 2.5. So paramagnetic and bond order lesser than O2, this is wrong. Bond order of O2 is 2 and bond order of O2 plus is 2.5. In second option it is written paramagnetic and bond order greater than O2, this is right. So its answer is 2. Sivanshu, right there, 2, very good. Yes. Next, question number 21. Which of the following boiling point order is not correct? And remember, higher the molar mass, more the BP. In general, higher the molecular weight, more will be the molecular weight, more will be the surface area of the molecule, more will be the van der Waals force of attraction between molecules, and so higher will be the BP. But in case of helium and H2, remember, boiling point of H2 is higher than that of helium. The helium has least boiling point among all the elements. Least boiling point is of helium, because in helium molar mass is 4, while in H2 molar mass is 2 only, but yet BP of H2 is higher than that of helium, because in H2 there is one sigma bond between 2H. So 2H and one sigma bond, so large molecule surface area, and larger the surface area of the molecule, more is the boiling point. Yes. No, in H2 no H bonding. For H bonding can take place in those molecules where H is covalently bonded to phone. That is, H is covalently bonded to F, or with O, or with N. Next, 22. The fluoride which is most soluble in water. These type of questions order have been mentioned in video lecture. Watch it carefully. I had said in different cases I have discussed these type of questions. So its right answer is for BEF2. And for detail, watch video of it. I have discussed these things in detail with concept. Right? Next, question number 23. Which of the following compounds give metal and oxygen gas at high temperature? And the answer is Ag2CO3, silver carbonate. On heating silver carbonate, you will get Ag plus CO2 gas plus O2 gas. Listen, here first you will get Ag2O. First you will get Ag2O plus CO2. But thermal stability of Ag2O is lesser than that of Ag2CO3. That is, the decomposition temperature of Ag2O is lesser than that of Ag2CO3. Therefore, at the temperature at which Ag2CO3 will decompose, at that temperature Ag2O can't exist. So, when Ag2CO3 will be decomposed, then Ag2O will not exist at that temperature, and Ag2O will get decomposed into Ag plus O2, and CO2 you will get here. So, These type of questions have been discussed in video lecture in detail. Watch it carefully. Now move to question number 24. Yes, thermal stability of ionic compounds have been discussed in video lecture in two cases, case 1 and case 2, with perfect reason. Watch it carefully. Next, 24. How many bond electron pair are present in white phosphorus? Listen, the structure of white phosphorus is P4. So P, this is P4, this is P4, and here you can see each P has one lone pair. Now there are 6 covalent bonds here, and one covalent bond means 2 bond pair, 1 bond electron pair, so 6 covalent bond, so 6 bond electron pair. So answer will be 1. Okay. Next, 25. A structure of carbon suboxide is. This is simple question. C3O2 carbon suboxide. Listen one thing. If number of O atoms is less than the number of the central atom, then such oxide will be called the suboxide, right? And the structure of suboxide is C double bond, C double bond, C double bond O, and double bond O. In suboxide there is CO bond as well as CC bond both, and all hybridization of all carbon here is SP, so this is linear. Okay, now move to question number 26. In O2 minus, O2 and O2 2 minus species, total number of anti-bonding electrons are respectively. Very simple question, and for that you will have to write the structure by mot of these, and then you can do such type of questions. So in 26 you can see the answer will be 1. In O2 minus, there will be 7 electrons in ABMO. In O2, there are 6 electrons in ABMO. And in O2 2 minus, naturally 8 electrons will be there in ABMO. So answer is 1. Everyone right? Now move to question number 27. I am skipping this. 27. Which of the following carbide of S block element gives methane on reaction with water? Such type of question have been discussed in the live session of chemical bonding part 1. You remember it? Be2C. In Be2C you can see the oxidation state of beryllium is +2. So +2 into 2 +4. So carbon must have -4. So this is methanide. On its hydrolysis, C4 minus will get 4H plus from 4 water and will give methane. This is methanide type of carbide. So this will give methanide, that is methane. Al4C3. Valency of aluminum is 3 and methanide type of carbide is C4 minus. C4 minus means valency 4, crisscross. So its formula will be Al4C3. This is aluminum carbide and anionic part of it is C4 minus. This is methanide type of carbide. Therefore on hydrolysis it will give methane. But CaC2. Here you can see Ca has +2, so C2 will have -2. C2 has -2, so it will accept 2H plus from 2 water, so it will become C2H2, and this will give acetylene. This is acetylide type of carbide. This has been discussed in the previous live session. So here the answer will be 4, both 1 and 2. Now move to question number 28. Yes, 28. Anis goes. 28. Which shows highest dipole moment? Naturally HF listen, F is most electronegative, and higher the electronegativity, more will be the difference of electronegativity between H and F, and in between H and F, electronegativity difference is more, therefore more ionic character will be in covalent bond, so more bond moment, so more dipole moment. So its answer will be HF. Now move to question number 29. In ClF3, lone pair of electrons present at, see here, ClF3, first find the hybridization of central atom Cl, and for that first find N. 7 3s are 21 plus 7, 28, divide 28 by 8, so quotient will be 3 and remainder will be 4. Remainder is 4, so 4 by 2, 2 lone pair on central atom. So steric number will be 5, so 5 orbitals of it will take part in hybridization. So hybridization of Cl here will be sp3d. sp3d means TBP. Its electronic geometry is TBP. Now, as you know, in TBP, lone pair occupies equatorial position. So lone pair, place lone pair on equatorial position. So in left position, F will occupy. This is equatorial F. These two F are axial. So both lone pair will occupy at equatorial position because it has a TBP structure, right? Now, Anis, no HCl, it is HF. For what? HF. I had said HF. HF has highest bond moment and so dipole moment among the halogen acids, among the hydroacids of halogens. Now the last question is 30. The number of pp bonds present in XeO3 and XeO4 minus molecules are number of pp bonds present in XeO3 and XeO4. Here is some misprinting. Please get it, its actual performa in question number 30. First see, in XeO4 is wrong. XeO4 is not a compound here. What is XeO4 is nothing, and it has been asked pp. No pp bond in between both. Both have pp. Because I had said I clearly mentioned in XeO3, one sp3 hybrid orbital has lone pair and 3 sp3 hybrid orbitals will form sigma bonds. So 4 sp3 hybrid orbitals involved in bonding, that is S and all the 3p involved in bonding. So these 3 pi bonds will be formed by non-axial d orbitals of xenon and p orbitals of O. So all these 3 pi bonds will be of p pi d pi type. So p pi d pi type, so no p pi type. So but in the question it has been written p pi, then answer will be 0. No p pi bond is there. Everyone right? So it should be p pi d pi. So make a correction in the question number 30, and in place of p pi write p pi d pi. And p pi d pi, then in XeO3 there are 3 p pi d pi bonds, and in XeO4 there will be 4 p pi d pi bonds, and then its answer will become 1. So this is typing mistake. Okay? Yes. Watch video carefully for chemical bonding and periodic properties. Thank you.